That's our convex lens, thicker at the center and then thinner in edges. So we will have to draw the principal axis here, and this is going to be the center of our lens. And remember, if you will have a ruler, you can have this point here from the lens all the way to this point. That's the focal point. Same measurement. You can have another point here. It's the center of curvature. Then we have the same length here with your F and then center of curvature. And it's going to be other side of the convex lens. Okay, again, this is going to be the object, and then the image will be formed when this light rays will meet. Okay, now let's do it by using the rules. I guess we will just be using the rules parallel ray rule and the center ray rule. I guess you can use the three or you can use the two rules as long as these light rays will meet. Yeah, that is where our image will be forming. Okay, so in parallel ray rule, so the parallel ray from the tip of the object touches the lens, and at the center it will refract. Again, refraction means bending of light. It will refract all the way through the focus. Okay, just like that, it refracts. When the light enters the lens, it will bend or it will refract. Next is the center ray rule. In the center ray rule, no refraction, no bending. If the light ray will pass through the center of the lens, it will move straightly. Okay, all right, let's do it. All right, okay, and this point here, that is where our image will form. Okay, but you always remember when the object is at C, the image will be formed at C on the other side of the lens. But my drawing is not perfect because I just you know construct it without rulers or protractor. So maybe can be able to change it. The perfect location of my C here or center of curvature will be this point. Okay, so this will be the center of curvature. I just change it to jive with the image formation if the object is at C. Okay, again, when the object is at C, the image formed at C, other side of the lens, other side of lens. And draw the image here. Okay, and yeah, if you notice, the sizes of object and image in this case looks not different, but if the object is at C or center of curvature, the image will form at C as well, and the size is same as the object. But in my drawing, it's not likely the same. But yeah, if you will have your protractor in your ruler, you can have the same size of your object and your image form. All right. If the object is at C, yeah, the image will be formed also at C. The size of the object and the size of the image form same. But then again, my drawing didn't say so. And then lastly, if you look at it, it's inverted. All right, inverted, or it's not. It's gonna be real, right? Because it's inverted. So these are the characteristic of the image formed when the object is at C. If the object is in between the center of curvature and our focal point, let's try to find out what kind of image will be formed. And yeah, in or on the other side of our convex lens here. Let's just apply the parallel and center ray rules because These rules are easier to do in constructing ray diagram. In parallel ray rule, the parallel ray or a ray passing through the lens must be parallel uh, with our principal axis. Okay, let's use another color. And what's next? It will refract, or there will be bending of the light ray. So it will go directly through the focus. Okay. And the next thing, it will go directly through the focus. And then the next center ray rule, no refraction, no bending of light. The light ray will just, pass through straightly. Okay, let's use another color. From tip going to the center and then passes through straightly. No bending. And if you can see, there's a point here where our rays meet. That is where our image will be formed. So in that case, let's try to know what kind of images form. It's of course inverted real image. And then if you notice the size of the object, remember this is our object, and when these rays will meet, we call it image. Remember that one. The image larger than the object. Okay, it's larger than the object. And what else? It's real inverted, and then it is formed. Okay, formed beyond center of curvature, other side of lens. I forgot this is the center of curvature. So that is where the image will be formed when the object is in between C and F. So it will form right here beyond center of curvature. All right, this time we will try to find out uh, where does the image form if our object is at or the object is beyond center of curvature. Remember, this is the center of curvature. This is going to be our focal point, and this will be the focal point in center of curvature on the other side of the lens. We'll still be dealing with convex lens, thicker center and then thinner in edges. Okay, best rule that I usually use, parallel and the center ray rule. Parallel, yeah, the ray is parallel to the principal axis, and then it will gonna bend all the way through the focus of our lens, right? And the center, when the object is gonna be the center of the lens, it will move straightly without bending. Let's do it. Let's have the parallel first. Parallel rule from tip of the object, from tip of the object, and then all the way through the lens, and then it will bend or refract through the focus, just like that. Next is our center. We will use another color. It will just pass through the center straightly without bending. So let's do it this way. All right, let's try to find out what kind of image will be formed here. From the point where these rays meet, that is where you can put the image form. Again, this is going to be the object. The term is the object, and then the image, when this rays will meet here, this is going to be the image. So what kind of images form? All right, the image form when our object is beyond C, away from C. All right, we have inverted, still inverted, so it's real image. And what else? If you compare the size of our object and our image form, it's smaller than object size. Okay, and what else? It is formed in between, in between center of center of curvature and focal point on the other side of lens. If you notice, it forms here in between focal point, and center of curvature. Now, I'm going to show you what kind of image will be formed, and at the same time, where is the location of the image formed if our object is at focal point, center of curvature of the lens, and then we have the focal point. If the object is there, our image will be formed where? Okay, so I forgot. I have to put it here. It's going to be the focal point and center of curvature on the other side of the convex lens. We're still dealing with convex lens. All right, so we will be using the parallel and center ray rule. Okay, so let's do it. Object is at focal point. So from tip, and once the light will, enter the lens, it will gonna refract or bend all the way through our focus or focal point. And next is our center ray. From tip of the object, no refraction, it will go directly through the center, just like that. So if you noticed, this lines, these are parallel to each other, meaning they will never meet. And if there will be no meeting of this rays here, so it's gonna be no image. So in this case, definitely no image. All right, but hypothetically, the image is like found in in infinity, and if you will try to recall in some other cases when we will be applying the formulas in doing this, we can also say that the image is you know very large, yeah, very large, and yeah, it's also be real, or it's gonna be inverted or real. But let's stick to no image. In higher physics, they will claim that it's very large and then real and inverted. But the image is like found in infinity, right? Because these two lines, couldn't be together. They will not meet at some point. Okay. Now I have here the last situation in which our object is at is between f and the lens or the convex lens, right? So that is where our image is located between f, sorry, between focal point and our lens. That's going to be the center, and let's put it here, the other side of the lens, focus, and the center, other side of the lens. Let's try to know the characteristic of the image formed here. Let's still apply the parallel ray and the center ray rules. Okay, now let's have the parallel first. So the ray should be parallel with our principal axis, and then it will refract once it enters the lens. Okay, remember this is our principal axis. And next, it will go directly through our focus. Now, next, we have the center rule, the center ray rule. No refraction, no bending, just a straight line. As long as it should pass the center here. All right, my apology. Looks like that. But if you notice, where lines are diverging, it will move away from each other. So in that case, we can trace back the light ray. So we will be using broken line here to trace the refracted the rays on the other side of the lens, because our this our because the green line didn't or doesn't refract, so it's not good to say you will trace the refracted rays. But yeah, in this case, just trace the rays that you have drawn. Okay, just like this, trace it, and then this one also trace it until these two will meet at some point here, and that is where you can put your image. Wow, image that is formed here is upright or erect, right? So in that case, it's not real, but it's a virtual image. And then if you notice the size of our object, larger than the object. Okay. And it forms in front of the lens, convex lens. So I hope you learn something from this video if you're new to this channel, and if this channel helps you in your review or in teaching convex lenses to your students. Yeah, feel free to comment and like or even subscribe to this channel. Thank you so much, and see you around in my next video. Bye for now.